Okay, we have seen a lot of details on the microarchitecture and also, well, on the performance. But when we have developers and we want to develop applications and using the software stack, we have an important piece here that we haven't mentioned yet, and is the operating system. So now, do you want to introduce yourself or? No. Okay, just to know. Um, we have Bila Surendra, that's a master technology from the Indian Institute of Technology at Madras, and he is currently working at the Center of Development and Advanced Computing in a leading research and development organization under the Ministry of Electronics and IT Government of India. So now the floor is yours.
Good evening, everyone. My name is Billa Surendra. Today I will be discussing about my research paper titled Development of Fedora Linux Distribution for RISC-V Architecture, that is without compressed instruction, RV64G. Here is my agenda. Here I am going to discuss about introduction, project motivation, objective of my project, implementation phases, results and testing, future work, and finally conclusion. Moving on to the introduction, RISC-V architecture offers a greater flexibility in developing a custom processor based on the need. On top of the base ISA, we can choose any of the standard extension to develop a processor based on a need. CDAC is a premier R&D organization in India. We have developed a variety of RISC-V boards. One of our processor design is RV64G variant, and that is without compressed instruction support. So we are building a complete software ecosystem for this. As part of this, we tested Linux kernel and embedded operating system on it. As part of building an ecosystem, we tried finding a suitable Linux distribution for our board from the major Linux distribution vendors, but we could not find the one. The motivation for developing a RV64G specific Fedora distribution is that many of the Linux distributions have been developed for RV64GC variant, but not for the RV64G variant. Like Fedora, Debian, Ubuntu, these kind of distributions already there for RV64GC variant. These RV64GC images I cannot test in my board because my board doesn't support for 16-bit compressed instructions. So in this case, I need to create a Linux distribution specifically for the RV64G variant from the scratch. We all know that RV64G is subset of RV64GC, but this difference in architecture still requires a dedicated solution. Next, I am going to talk about the objective of my project. The objective of my project is to build a stable Fedora Linux distribution for the RISC-V RV64G variant and enabling a broader adoption in HPC and other applications. And understanding the unique needs and technical details of the RISC-V RV64G for building a Linux from the scratch. And here is my project overview. First, we are setting up the file system hierarchy, then generating a RISC-V cross compiler, and with the help of RISC-V cross compiler, we are cross compiling a basic packages which are required for the target image, and then integrating a native toolchain in my image, and building a minimal set of RPM packages in target image. And also, we are applying downstream patches for the Linux kernel to support for RV64G variant specific. And finally, we are setting up the cozy infrastructure for mass rebuilding of the packages for the required variant, like for RV64G. Next, in the implementation phases, the first step is creating a file system hierarchy structure based on the Linux file system hierarchy standard, like all other Linux distributions are following. like in, in this phase, by using x86 native toolchain, we are creating the RISC-V cross toolchain. And by using this RISC-V cross toolchain, we are cross-compiling the basic packages which are required for the target image, like bootloader, Linux kernel, and some user space applications. Next, in this phase, using RISC-V native toolchain, we are rebuilding all other packages till to get a RPM build inside the image. And then, by using this RPM build, we are rebuilding RPM packages natively in the target image itself. And this is the final stage where we set up a cozy infrastructure, and we begin building a packages for the RV64G variant, and we are maintaining a local repository for storing these binary packages. And this is our cozy instance snapshot. Like, this is cozy web. We can see the status of the packages, like which package is built, which package is like failed. This status we can see in this cozy web page. And all other activities of the cozy hub, we can see it here. Next, I am going to talk about the booting sequence which we have used for booting our Linux kernel. Initial boot flow, we have used OpenSBI and U-boot for booting our kernel image. And the current boot flow, we have introduced grub2 for easier selection of the required kernel version. And this is similar like a modern PC architecture PC booting sequence. And in future, we are targeting for replacing a U-boot with UDK2 firmware and making a our booting sequence similar to x86 booting sequence. Next, I'm going to talk about the results and testing. We have tested our image in QEMU. In QEMU, we have disabled compressed instruction facility and then booted our image successfully and tested the initial stability of the image. And also we have tested our image in CDAC Vega board. And for this, we have configured kernel for the specific our hardware and booted with the stable performance. And finally, we have tested Star5 board as well. We have configured some kernel settings for the Star5 board and then booted, and all functions are working as we expected. Next, a future work. In future, we are planning to expand the number of packages in our repository. Right now, 5,000 plus packages are there, and we are able to create a minimal Fedora as well as developer version Fedora distributions. And future, we are going to add more number of packages into our repository. And also, in future, we are going to develop a Fedora server version for RISC-V, that is for RV64G-CV variant as well. And we are going to rebuild HPC application RPM packages for the RISC-V architecture and making a complete ecosystem development for high-performance computing. Now I am concluding my work. Our work is addressing the current need of RV64G system and providing a scalable and maintainable solution to bridge the ecosystem gap and promote the RISC-V adoption. And these techniques which we have followed for building a Linux distribution for RISC-V architecture or without compressed instruction can be used for other Linux distribution as well, including Alma Linux and Rocky Linux. Thank you.
Thank you. You were super fast. Questions?
Thanks for the nice talk. Will you allow other users to submit packages, or can I submit a package to your Fedora distribution or not?
No, actually, we are maintaining right now we are maintaining our local server only. So if you want to, like in future, we are planning to making it as open.
Okay.
Then you can submit your package to our server that will rebuild it and it will keep it in a repository that you can use it.
Okay, thank you.
Thank you. What was the decision that led to not implementing the C compressed instructions in the CDEC processor? Thank you.
Actually, we have variety of processor, RISC-V processor we have developed, but this is one of our board. Like you can say that initial board it is. So we started doing this research work on that board, and in future we are applying for all the variants of RISC-V extensions. Sorry.
Why vendors don't implement C?
Yeah, we are working on parallelly.
So as researchers, I mean, the first step is not implementing the C. So it's useful to have something like this because we are struggling usually for having this kind of images. So having something homogeneous or something available there saves some of our time. And then the next step, whereas we are implementing the C, which is sometimes it's not very easy, then we can use the standard images. So I think
Since process is known, like we can implement it for any extension.
One more question? Okay.
So the motivation of the C instruction was to reduce code size. Have you done any comparisons against the RV64GC distributions to see how much the RPMs grew as an example?
So we didn't thought with respect to the size, like we obviously without C is having a more executable size, but since we started with this without C support, so we finished this, and like now we are comfortable to develop a distribution for any extension. So we are working on it for in future.
Thank you.